Okay, so the goal for today is going to be to create a cartoon of the transfer of energy for this energy source that you've been assigned. So in this case, it'll be wind energy. The agenda, you're going to draw cartoons for your energy source to learn how they work and how energy is transferred inside of it. Okay, so the wind energy slide, well, the first slide on here is going to be the exact same as the solar energy slide. And that's because all of the wind energy on Earth comes from the sun. And so inside the sun, we've got different atoms. And what happens to those atoms is they get smashed. They have nuclear energy inside of them. And they get smashed together in a process called fusion. So those atoms get fused together. They get like smashed together. And then what happens after they get smashed together is they actually split apart. And when they split apart, there's some energy released. And that energy gets released in the form of heat, but also light. And that light energy travels across space towards Earth. So this is kind of what you want to draw. I would draw two different atomic nuclei smashing together, and then draw the atoms splitting apart, and then show that some energy or light is being released in that process. Okay, and so then for panel 2, what you're going to draw is the sun and the earth, and you're going to draw the light rays from the sun going to Earth. And so what you're going to say is the light energy travels from the sun to the earth. Okay? And so then in the next slide, what we're going to show is the light from the sun coming into Earth, and it sort of bounces off of our that light bounces off of our atmosphere, right? So that's what's happening here is the light energy comes in, and then but once it enters, it can't actually leave because it sort of just bounces off of our atmosphere. And so this happens because CO2 and other gases in the atmosphere trap the heat and keep the Earth warm. So what's happening here is the light energy is being turned into heat energy, and this is because of the greenhouse effect. Okay? So what you're going to draw for this slide is the sun and the Earth, and you're going to want to kind of draw like a bubble around the Earth to represent the atmosphere, and then just show that the light gets trapped inside as heat. Okay, so here's for slide 4, you're going to draw a model of the Earth with the North Pole, the South Pole, and the equator. And what you should notice is that the North Pole and the South Pole are a lot colder than it is at the equator. And that's because the heating is uneven, right? The equator gets heated a lot more than the poles do. And so then what ends up happening is the hot moves up to the cold, and the cold moves down to the hot, and that happens through what we call wind, right? And so that's how wind actually forms, is because of the uneven heating on the Earth. The hot spots want to move to the cold, and the cold spots want to move to the hot, and that's where the winds come from. And so what ends up happening is that heat energy is transformed into kinetic energy, and that kinetic energy is in the form of wind. So go ahead and draw the Earth, show the hot and cold spots, and try to kind of draw the motion of the hot moving to the cold and the cold moving to the hot, because that's kind of where the wind comes from. Okay, and then for slide 5, you're going to draw some wind, and then you're also going to draw, and remember that the wind has kinetic energy, and then you're also going to draw a turbine. All right, so what's happening is that wind, the kinetic energy of the wind is blowing into this wind turbine, and that kinetic energy of the wind is transformed into mechanical energy, right? Because it makes that turbine spin around. If we want to sort of, okay, and so then, so for this slide, you're going to draw some wind, a turbine, and you're going to draw the turbine moving. Okay, and so then we're going to draw our turbine again here. And so remember that, whoops, so sorry about that. The kinetic energy of the wind is actually transformed, into mechanical energy. Oh, whoops, and so then the mechanical energy of the turbine, I didn't know that said kinetic before. That should say mechanical for slide 6. The mechanical energy of the turbine is transformed into, well, we'll see what it's transformed into. What's actually happening here is as the turbine spins, this is sort of an image of what's going on the inside. What's happening is the turbine's actually spinning a generator. Now, what happens when you spin a generator is you generate electricity. Let's kind of show that right here. We've got a guy spinning a generator, and you can see the little light bulb lights up. That's because electricity is going through. So here, let's look at that on full screen here. Might make it a little bit easier to see. So he's spinning this generator. He's cranking it, and when he does that, look what happens. The light lights up. So this is a process called electromagnetic induction. What's going on here is this metal coil is spinning inside of a magnet. And whenever you do that, whenever you move metal inside a magnet or move a magnet inside of metal, you induce what's called a magnetic current or an electrical current. Okay, and so a lot of your different energy sources will use that same idea. Okay, and so we're spinning the turbine. The turbine spins the generator. That's going to generate electricity. And so the mechanical energy of the turbine is transformed into electric energy. God dang it. Sorry, another mistake there. That said kinetic there before, but it should have said mechanical. So the mechanical energy of the turbine is transformed into electric energy as the turbine turns the generator. And so again, this is a process that you're going to see in basically every single energy source that we go over here except for solar power. Solar power is sort of the odd one out. It only, it doesn't use a turbine or a generator, but all the other ones do. Okay, and so then the electric energy, it flows down the turbine here. So you're going to want to draw a turbine again with a wire coming out. And then the electric energy is carried to people's houses. So we can see the electric energy going up the wire, and it kind of feeds into the power lines, right? And the power lines carry the energy. So really the electric energy is carried to people's houses through the power lines. And that's how we get energy from a wind turbine. Okay, so let me know if you have any questions.